So, we're going to talk about a little RNS, and I'm going to show you a few tricks that you can use. Of course, so first off, let me state that enantiomers is the only place you're applying RNS. That means it has to be chiral. So there is no such thing as a achiral R or S, right? The other part of that is RNS has strict rules for assigning it. So one of the things that I hear all the time is, I'll go ahead and make an example that we'll use later. Watch out, fluorine and back in. Whatever, good enough. Okay, so this was me an example of something that has chirality and can have an enantiomer, right? See that? Okay, so because you can make a mirror image that would not be superimposable. It's actually what also makes it chiral, right? Okay, so I get this all the time that people go, okay, so if I look at this direction, look at from this perspective, this is going to be, and then they go ahead and do RNS. So they go, okay, the thing in the back, I don't count. I then look around, chlorine, fluorine, hydrogen, that would be the order there. And so that would be going this direction, and that would be S, right? No. The rules for RNS start with putting hydrogen in the back. That's the beginning of it, right? That's like saying any direction I happen to be facing could be north. Because my map's facing that direction, right? Doesn't work that way. It is a standardized orientation, right? If you don't face north, your map doesn't work, does it? So no, that is not S, because it happens that you can, do the priorities in any direction you damn well please. That's not how that works, right? Much like north is not any direction you happen to face, okay? North has a very specific meaning being oriented towards the north pole of this planet, right? Okay. All right. So, what would actually work? Well, you need the hydrogen facing backwards, right? Okay. And so we go ahead and go like that. Now, there's two ways you could have assigned RNS for this enantiomer, right? One way is the way that I was talking about the other day. And what you can do there is you rotate the enantiomer. So hydrogen is facing backwards. It has come to my attention and been reinforced to my attention that this is actually a very rare subset of people that can do this. Like the vast majority of people have a lot of trouble with this. So I do not have trouble with this, so I did not think it was, I knew that, I thought it was like 50-50. I did not realize it was like 80% can't do it. So I'm going to teach you an alternative way that does not require you to rotate this in your head. Okay? Okay. So let's go ahead and redraw this. And what we're going to do is, if the hydrogen is in the plane of the paper, okay? Meaning it's that flat thing, right? What I'm going to do is, well, what is the definition for an enantiomer? The definition is exchanging any two groups, and that will give you the enantiomer. So if I started off with an R, let's say, okay? Then if I exchange any two groups on this, what will I have? The opposite. I'll have an S, won't I? Okay. So what I'm going to do is I'm going to use the fact that I can exchange any two groups on this, and I will get the opposite to just go ahead and figure this out. So I'm going to exchange hydrogen with the one in the back. bromine, right? So I exchanged it there. That means my Br is going to be on this bond. See that? And I'm going to try to copy these as best I can. Okay. You see what I did there? I went ahead and made the enantiomer, didn't I? Okay. And always swap it so the lowest priority group is in the back. And then whatever was in the back goes to where you did that lowest priority group from, where you took that from. Now I assign my priorities. The priorities are directly atomic numbers, aren't they? And so this is what priority? 1, yep. And that's 2, and then this would be 3, yeah. And so it's going that direction. That would make this enantiomer.
This would be 1, 2, you're going clockwise, it would be R. What?
That's
what?
Clockwise?
Wait, hold on. Oh. See, look, I can't even do the clock in my head. Step in.
You did this and go clockwise.
Yeah, I'm thinking about, I was just thinking about
You were doing it right, too. You just said the wrong thing.
Is counterclockwise.
Yeah, it's counterclockwise S, right?
Yes.
Yeah. Or another way of saying that is left S.
Don't worry, guys. That's why I come every day.
That's funny. Okay, you're okay. Okay, so the enantiomer is S. The original then has to be the opposite, doesn't it? Meaning R. See that? And so I can play a nice little trick that makes this really trivially easy, right? Huh?
So what was the question? We did all this just to get the opposite one?
Well, it actually isn't a lot of work. It's super fast and easy, but you all asked me a lot of questions.
Gotcha. But like, if they did ask the question, you would do this and then just
Yes,
do the
so
opposite?
what is the, which is this, R or S, or not applicable? That would be the question.
Okay.
And if it's non-applicable, that means they have symmetry, right?
Yes, so if you had something like with 2 hydrogens on it, that's not chiral, right?
Yeah, because of hydrogen in the back. And so
Yeah, you can exchange these and it wouldn't make any difference, right?
that's what when we did it Wednesday, we were like, if it only has like 2 groups off of it or something like that, then it's, you can't work it.
Yeah, you cannot be chiral. There's just not enough detail. It has a plane of symmetry in it. Or another way of thinking that is the way to make an enantiomer would be to swap 2 groups on it. If you have 2 hydrogens, it doesn't matter, does it? 2 of the same group, swap them, no new enantiomer, same damn thing. Okay, let's say you have a ring. It's really hard to line these things up on my deal. It just don't work well. And so then you have like what do I want to put on here? Hydrogen and a fluorine. Okay. Okay, that's not a double bond, by the way. That's just me having trouble lining these things up. Okay. So if you have a ring like this, right? Well, again, that's going to be chiral, isn't it? Because you have a different number of carbons here. So that'd be 1, 1. Oh. Let's put a CH there. There. Okay. So now this is a chiral center, right? And so that's not there is no not A, right? In A. We need to assign this an R or S. So how do we go about this? Is the F in the back? Yeah, you gotta figure out what's coming towards you, what is coming, going away from you, right? So what's what? So we need to flatten this out, don't we? Well, we need to flatten this out a way that we actually understand what its geometry is. So what is the geometry of this dang thing?
Is that what we're asking the pin tank?
No.
Oh.
Well, we don't care how big the ring is. All we care is this chiral, and what is the geometry around there? Okay. The easiest way to deal with this is to look down this bond here. I mean, it's a tetrahedral shape, yes, but that doesn't actually, that's not going to help you because you don't know which one's back, forwards, right? Yeah. So yes, this is a tetrahedral shape. All carbons with 4 things on them are tetrahedral. Okay. The easy way to deal with this and look at it is to rewrite this carbon. Okay? So we have a carbon right there. The ring, we can look down this bond very easily, can't we? See that? So if that bond that's in this ring is going away from us, I'm going to put a 1 with a circle here. Okay? Actually, let's not use numbers. I'm going to put an A with a circle, okay? A. So this is going down that ring, right? That's going away from you. That means this part has to be coming out towards me, doesn't it? So let's call that B, portion of the ring. Okay? Now, what's the next thing? Well, my F right here, right? If I have 1 coming out towards me, 1 going away from me, then those are both in the plane, aren't they? So my hydrogen and my fluorine are in the plane. Because that's tetrahedral geometry. 3 of the things have to be in the plane. 1 comes out towards you, 1 goes away from you, right? All right. But that still didn't get me my damn hydrogen in the right place, right? It's in the plane, isn't it? Well, damn. So what do? Yeah, I go ahead and swap the H with A here, right? And I make the other enantiomer. Always swap the lowest priority so it's facing backwards. That's enough. Oh, I'm having real troubles getting things lined up on this. I don't have any space to put my damn hand. All right. So, now what we have to do, we're looking at this one here. Well, we have to figure out priorities, don't we? Okay, so A, first off, what's your first priority? Highest priority? Yeah, fluorine, right? Your next highest priority is the one that runs out of the carbons last, right? Let's put, you want to put a double bond in here just to make it easy on you? Okay. So priority A, let's call it, okay? Okay. And then B would be your last priority, right? Okay. We then look at this. This is going this direction. So that B. Is that clockwise? Yep. And this one, the right one, the first enantiomer, the one we were given, is R. Okay? Notice that this is actually kind of the same thing we were doing when we had the hydrogens in front. Remember where I was showing you that shortcut with the hydrogen in front? Okay. It's really loud. Yeah, it does seem like it, doesn't it? Wow. Okay, let's do hydrogen in front. Oops. Okay, so we have a hydrogen coming out towards us, right? Instead of fading away from us, like it should be. So there's two different ways we can do this, right? All right. The way I had taught you the other day was you just go ahead and assign this RS using the priorities. Just don't worry about the fact that's a hydrogen in front. Just treat it like it's in the back. So don't worry about it. So which one has higher priority, the fluorine or the oxygen? Yeah, the fluorine would have the highest priority between the two. Oxygen would be number 2. That's going that direction, isn't it? See that?
Yeah, well, hold up.
The reason it's not declining is from say chlorine, but it's because the chlorine's in the back, right?
Yes, chlorine's in the back.
What, this is if you didn't put the H in the back?
Yeah, if you don't bother swapping them,
This is a shortcut?
this is a shortcut when the H is in the front.
Only when the H is in the front?
Only when the H is in the front. Okay? You can optimize, make this shorter.
When the H is in the front, you don't care what's in the back.
You just act like it's in the back. Okay? So whatever's in the back, you act like that's the H in the back. And so you go fluorine, oxygen, it's that direction. That would give you your S, right? Okay. Well, you flip it then, so it'd actually be R, because you're doing backwards, aren't you? Okay. The alternative way to do this is the same way I just showed you to do before, right? Remember, you can swap any two things, and that will always give you the enantiomer, right? So I swap my H and my Cl. And that's my other enantiomer, isn't it?
Clockwise is S, or is it counterclockwise S?
Oh, this is S.
Clockwise is the right way. And the right way is clockwise and the counter.
I did it for what it actually is, right? So we would have gotten S from doing this, right? But it's not actually S.
Yeah.
Yeah. So you'd answer it R, because it'd be opposite. Okay. So we can also do it alternatively, the same way I just taught you for those other things. Remember that anytime you swap two of these groups on a chiral carbon, you get the enantiomer. So if you swap the hydrogen to the back position and then put the chlorine in front, that gives you the enantiomer, right? So this would be 1, 2, we don't have to do anything. 3. So hydrogen's in the back. So we go ahead and do this. We get what? S. Yep, counterclockwise S. Well, remember, we made the enantiomer. Enantiomers are always the opposite, right? So that means the true designation is R. So you see how what I taught you was an abbreviated version of this, that you could quickly and easily do this. Okay? Yeah. Because I essentially just taught you everything but swapping them in that previous method. See that? We can cut out that swap step. Okay, does anybody have any questions about these? Want to try to do some problems?
Oh, yes. Let's try
Alright.
the problem.
You all pull up those problems and attempt them.